In part 2, we're going to be discussing the length of a circular arc and the area of a sector. So the length of a circular arc is a part of the circumference of a circle Something we already know about about a circle is the circumference formula, which we know circumference is equal to 2 pi r, and s is a fraction of the circumference, which we know s is equal to theta over 2 pi times the circumference. To develop the formula for arc length, we take s equals theta over 2 pi, and we multiply that by the circumference, which we know is 2 pi r divided by 1. So 2 pi r over 1. Reducing this down, we are left with theta times r, where theta is our central angle, r is our radius, and s is our arc length. So our formula, s equals r times theta, where r is the radius of the circle, s is the arc length, and theta is the central angle. It's important to note that theta is always in radians. So if you are given a problem and it gives you theta in degrees, you need to convert theta to radians. So for our example, it says find the length of an arc of a circle with a radius of 14 inches that subtends a central angle of 30 degrees. So we're given two pieces of information. We're given that radius equals 14 inches and that theta equals 30 degrees. Since theta is given to us in degrees, we need to convert that to radians, which is pi over 6 radians. So now using the formula for arc length, we have s equals r times theta. So s equals 14 times pi over 6, which reduces to 7 pi over 3 inches, or 7.33 inches. Next, we're going to be discussing the area of a sector, which the area of a sector is a part of the area of a circle. So, known facts about a circle. The area formula is pi r squared, and A is this fraction of the area. We know A is equal to theta over 2 pi times the area. So in order to develop this formula or derive it, we take A equals theta over 2 pi and we multiply by the area formula, which is pi r squared over 1. After simplifying, we are left with A equals 1/2 r squared theta. Again, where theta is our central angle and r is our radius. So our new formula we created, we have A equals 1/2 r squared theta, or A equals r squared theta over 2. They're both equivalent. And again, where r is the radius of the circle, A is the area of the sector, and theta is the central angle. And again, the central angle is always in degrees. always in radians. So if your central angle is given to you in degrees, you must convert it to radians in order to solve the problem completely. So for our example, it says find the area of a sector of a circle with a diameter of 16 centimeters that subtends a central angle of 2 pi over 5. So we know that our angle is 2 pi over 5, which is already in radians, so we do not need to convert. And we're also given that our diameter is 16 centimeters. If we need to know what our radians is, so 16 divided by 2, 8 centimeters. So our radius is 8 centimeters. Now using our formula, we have A equals 1/2 r squared theta. We have 1/2 r squared. So 8 squared times our theta, which is 2 pi over 5. Reducing this down, we are left with 64 pi over 5 centimeters squared, which is equivalent to roughly 40.2 centimeters squared.